The first step in any data visualization project is to get the data. If you don't have data, there's nothing to visualize. As soon as you get access to data that you want to visualize, loading data into your program becomes the primary concern. We'll discuss HTTP requests, fetch, Sentinel value, the Iris dataset, quantitative versus categorical columns, promises, parsing CSV data, Unary plus, the typeof operator, and JSON.stringify. To load data, the front end needs to make a request to some server. That server looks to the file system to read CSV or JSON files. Those are just text files on disk that get loaded into memory in the server and then sent back to the front end. This happens over a protocol called HTTP, Hypertext Transfer Protocol. When we write JavaScript code that loads data, we need to use what's called the fetch API. The fetch method is what will initiate our HTTP request to the server. Let's go ahead and write a program that fetches a text file. I'm going to start by forking our mouse follower example, and I'll call it loading data. I'm starting with this example because I also want to introduce how loading data plays with this notion of unidirectional data flow. I want to treat the data of our viz as yet another piece of state. That state could be not yet started loading, in the process of being loaded, meaning the HTTP request was sent out but the response hasn't came back yet, or loaded, finished. Let's start by gutting our previous viz. All that we're left with now is a very simple starting point that defines a function called viz, and we have a container, which is a DOM element that we can inject things into, and then our two friends, state and setState. Now, state.data is going to be a thing, which could be undefined. That's what it is at first, before anything happens. Or it could be loading. I'm thinking it could just have the value of loading, the string loading. This is what's called a Sentinel value, a very specific value that has a very specific meaning. This is the state that it will be in after the fetch has been initiated, meaning the HTTP request has been sent out, but before the response comes back. So if it's loading, then this is the time to show like a loading spinner or something like that if you wanted to. Or it could be an array of objects. This is what it will be after the data has been loaded and parsed from like a CSV file into this array of objects, which is the conventional way of representing a data table in memory using JavaScript with D3 in particular. Each object in this array will correspond to a row of the table, and the properties of these objects will correspond to columns of the table. All right, so let's get started by unpacking data from our state object using destructuring. Now, if data is undefined, that's when we know we should kick off a fetch because the data has not even started loading yet. All right, so if data is undefined, this is when we fetch. What are we going to fetch though? We don't have any data. We don't have any files yet. Let's say we want to fetch a file called data.csv. I'm going to make a new file called data.csv, and I'm going to put some data in here. I'm going to use the Iris dataset from the UCI machine learning repository. This is a classic dataset about flowers that is used, perhaps overused, in data science and teaching machine learning and data visualization. This is the data set that I learned on many years ago, and I think it's fantastic. I mean, it creates beautiful scatter plots. And luckily, I posted this data set as a GitHub gist with a README that describes it a little bit, a page that displays it, and the data itself. All right, this is pretty sweet. This is GitHub's way of presenting a CSV file nicely as an HTML table. There are 4 columns here whose values are all numbers. That means these are quantitative columns, also called attributes sometimes. And there's 1 column that has strings for values. Actually, there's 3 distinct values that it could possibly have. This is a categorical column because it doesn't have numbers. It has strings or distinct identifiers that don't have any natural order. They're just different things. That's a categorical column or attribute. These are actually different measurements of iris flowers. In this post by Rafael Santos, he's got this nice image of various species of iris flower. And you see this here is the sepal, and this here is the petal, each of which have length, which I guess is the direction away from the root, and width. So that's what these various columns mean. And there are 150 rows representing 150 different individual flowers. This numbering is a little misleading or confusing because it says 151, but there are actually 150 rows. This is because these are actually line numbers in the text file. And line 1 corresponds to what's called the header row that just contains the column names. If we take a look at the raw version of this text file, we can see that it's the same values that we saw in that really nice table view, but they're just delimited by commas. The values are separated by commas. That's why it's called CSV, comma separated values. All right, this is the text that we want in our file. So I'm just going to select all of it and copy it, and then back in data.csv, I'll just paste it. Now data.csv is actually a CSV file. Over in viz.js, this should actually work now. Let's figure out how to invoke fetch. This article called Using the Fetch API is really good. It contains some nice examples, like this one here. This one fetches a JSON file and then parses that file as JSON, then console.logs that data. Let's try out this code. I'm going to comment out this code for the time being and paste that example from MDN. If we run this code, it fails because that's not actually a place that exists. But let me try this. Let me just put data.csv in place of that URL. And then instead of .json, let's try .text. Now it actually outputs the content of our file. This .then syntax is from a thing called promises. The promise object represents the eventual completion or failure of an asynchronous operation and its returning value. A promise is in one of these states: pending, fulfilled, or rejected. In the case of our fetch promise, at the time that the fetch function returns its promise, it is in a pending state, meaning the HTTP request just went out And we haven't heard back yet. But how will we know when that data comes in? When that request comes back? That's when the promise transitions from pending to fulfilled, unless there was an error, in which case it gets rejected. But let's just pretend that it'll always be fulfilled. We need to provide a way to execute our code at some time in the future, and that is done by passing in a callback function to .then. Check it out. Fetch itself returns a promise. Promises have a method on them called then. We pass in a function to promise.then that takes as input something, and that something is the value that the promise resolves with. In this case, that is the response to our request. This is part of the response interface of the Fetch API. This response object has a number of instance methods, including .json and .text. The text method of the response interface takes a response and it reads it out to completion, and then it returns a promise that resolves with a string. All that is to say, it just gets the text and gives us a JavaScript string. But we got to realize that this method itself also returns a promise. So this getting the text out of the response is also asynchronous. It could take some time. Check out what's going on here. This is actually an implicit return from this arrow function. And response.text returns a promise. One of the really cool things about promises is that you can chain them. Meaning, if the callback function that gets passed into .then returns a promise, then what you can do is call .then on the returned value from .then to the original promise. So there's actually two asynchronous things that are happening here. The original fetch, and then the asynchronous process that gets the text out of the response. When all that's said and done, this function here will get invoked with, we're just going to call it data. We could call it anything. This is the string that is inside of our CSV file. At this point, we're still dealing with a string, just the text of the CSV file. The next step is to parse this CSV string into the array of objects I was talking about earlier. Luckily, D3 has a utility that we can import called CSV parse. After we import CSV parse from D3, we can pass our data into it. And before I do that, I'm just going to rename data to CSV string, just so that it's super clear what that is. And then in the body of this final callback, I'm going to invoke CSV parse, passing in our CSV string. This function will return the array of objects that we will ultimately call data. So let's check if it worked by saying console.log data. All right, this looks promising. It says here we have 150 objects in an array. In the Chrome DevTools, when you console.log an array or an object, it gives you this really nice inspector thing that you can use to drill down and see what the structure of it is. We can see here that at index 0 of the array, meaning it's the first element of this array, we have an object that has these key value pairs. The keys correspond to the column names, and the values correspond to the values that you see in the cell. The first row has a sepal length of 5.1. And sure enough, the sepal length property of the row object at index 0 of our data array is also 5.1. But that's a string, man. That is a string because it has quotes around it. That will not do as soon as we want to start doing math on the data. So, we really need to parse those strings into numbers before we can use them. But how do we do that? Check this out. If I take the string 5.1 and I drop it in the console, okay, it's a string. Now, there is a built-in function called parse float. If I pass the string 5.1 into parse float, it returns a floating point number. This is one way you can parse strings to numbers. There's also a very concise way, which is plus. If I just say plus 5.1, that will also parse the string into a number. This is the Unary plus operator. This is just kind of a quirky operator in JavaScript that attempts to convert things into numbers. It's got some nice examples in here. Plus hello is not a number. Interestingly, plus true is 1 and plus false is 0. But yeah, if we use it on strings that represent numbers, it will parse those strings to numbers. So what we want to do here is take a look at each and every row object and then parse these columns that are supposed to be numbers but are strings right now into numbers, and then write that value back into the row object by mutating it. That's what we're going to do. Since data is an array of objects, we can iterate over that by saying for const d of data console.log d. And by the way, d is just a convention that you'll see in a lot of D3 examples. D usually refers to one row of data. It's just a popular naming convention. To reduce confusion, I'm going to remove this console.log data, and let's see what we get. Now what we're getting is these individual separate objects, each being printed out to the console one by one. These 4 keys are the ones that we want to parse into numbers. The first step is accessing these values, these string values. So if we wanted to get at, let's say, petal length, we can say d dot petal length. Now it's printing out all the string values for petal length. Now if we change this to say plus d dot petal length, now it outputs numbers. But it's hard to tell because they look kind of the same. Here's a neat trick. We can say typeof, which is another funny operator in JavaScript. This will just tell us what type the following thing is. So right now we can see that they're all strings. But if we add that plus, they're all numbers, which is what we want. Typically, what we do after we parse the string into a number is to assign that number to the property of the row object that was originally a string. Now, if we console.log data, we can see pretty clearly that petal length is now a number, but everything else is strings. Now we just have to do the same for all 4 of these columns. If we take a look now, we can see that all of these values are numbers except species, which is still a string, and that's fine. All right, we've got our parsed data as an array of objects. Now it's coming full circle. What we're going to do is integrate this back into our unidirectional data flow by setting the state to a new state that has the data there. We can do this by invoking our setState function, passing a callback function that takes as input the previous version of the state and returns a new object. Quick aside, I hit an infinite loop and then I added #recover to the end of the URL, which you can do sometimes if it crashes on you. That returned object is going to contain the previous state, whatever was on there, and also data, the new value for data. Now, if this were to run, it would be an infinite loop. You know why? Because we never set the value to loading. The first time our function is invoked, data will be undefined. If we call setState and just, set it to be state with no data, then data will be undefined again and again and again and again. So really what we should do is right before we fetch our CSV, we should set the state so that data is loading. That way, whatever happens while the data is loading, it will not trigger this again because data itself will not be undefined. So first we'll do that. We set the data state to be loading, and then we kick off our fetch. After some time, then we call setState that will set the data field to be the value of data, this variable here. And by the way, there's a shorthand in JavaScript if you have the key name matching the name of a local variable. You can just simplify this to data. It's the same thing. To check if that worked, I'm going to move this console.log data out to the top level of our function. And just for clarity's sake, I'm going to say console.log state.data. This will be coming from our state object now. Check it out. At first, it's undefined. Then it transitions to loading. And then it transitions to this array of row objects, which is super cool. And these have the numbers parsed into strings. Fun fact, the D3 CSV parsing actually returns an array of object that also has a property on it called columns, which is just a list of the columns. Wait, so you're telling me that an array can have properties on it? Yeah, it's one of these totally weird and wacky things about JavaScript, but D3 uses this quite often, so it's good to know about. Here's an example. Let's say we have an array, 1, 2, 3. We can actually say something like array.foo equals bar, which is random strings here. And then if we console.log array, it's an array that has 1, 2, 3, but it also has a property. Yeah, super weird, right? But, sometimes you'll see this in the wild. But anyway, this is how we can load and parse data using D3 and unidirectional data flow. To wrap this up, I just want to write some code that presents the data in some way. For that, we're going to do some form of DOM manipulation. So right off the bat, we need to import select from D3 and select our container, which, remember, is just a DOM element. I think it's a div. And then, I think I'll just append a pre-element, which is a DOM element, kind of like a div or a span, or something like that, you can put text in it, and what it means it means pre-formatted text. I want to just show the data in some kind of representation, and I think the easiest way to show it, I think, is as JSON. JSON, by the way, stands for JavaScript Object Notation. But first, how do we get our data into JSON? This sounds crazy. Well, there's a utility called JSON.stringify. This output looks like this. First it's undefined, then it's loading, and this is really what we're after. It's a JSON representation of that array of objects. It's just a very long string. And interestingly, the dev tools say show more, 14.5 kilobytes. It's a useful way to know how big your data generally is. We can format this nicely by passing some additional arguments to JSON.stringify, namely null and 2. I don't remember what the second argument means, but 2 is the indentation level. So if we put 4, it's going to indent by 4 spaces and give this nice, pretty view. And I generally like to use 2 as the indentation. So this JSON here is what we can set as the text of our pre-DOM element. And when this runs, it looks something like this. It says loading, and then it's got this JSON stuff here. But wait a minute. Why does it show loading and the data at the same time? That doesn't happen. It's loading, and then it changes to be the loaded data. Well, we're running into that same old bug because we are appending new elements every time this code runs. Because we're using unidirectional data flow, and our viz function may execute again and again and again as the state changes, we need to use the general update pattern, which looks something like this. Select container.selectAllPre.data null, and then instead of .append, it's .join. Now you can see, if you catch it for a split second, it says loading, and then it transitions to the final result here. As a very last finishing touch, I'm just going to make this text a little bigger so we can actually read it by saying font size is 24 pixels maybe. And for this one, I don't want overflow hidden because for this, I kind of like the scroll bar. See, we can scroll down now and just see a preview of some rows of the data. All right, there's a lot going on here. Let me do a quick recap of this whole thing. Our viz function takes as input a container, a DOM element, the current value of the state, and a function to update the state called setState. This logic here renders a single pre-element whose text content is the JSON representation of state.data, whatever that may be. And state.data could be undefined, which it is at first, loading, which it is while the data is loading, after the HTTP request gets sent off, but before the HTTP response comes back, or an array of objects parsed from our CSV. Now here's the part that will actually fetch the data. If the data is undefined, meaning we're calling this for the first time ever, we set the state so that the value of the data property of our state object is set to the string loading. This is a Sentinel value. That just means, we're still waiting. And then we kick off the fetch process for our data.csv, which is this text file that contains CSV data. Once the initial promise returned by fetch resolves to a response object, we invoke response.text, which is another asynchronous method that will actually just get the text content out of that response as a string, namely this CSV string that we can pass into the CSV parse function provided by D3. This we call data, an array of row objects, and each row object is referred to as D, just by convention. We iterate through each row of the data, parsing these strings into numbers using Unary plus. Finally, we invoke setState with a callback function that takes as input the previous version of the state and returns a new state using immutable update patterns, where it copies all the other fields on the state. And there are no other fields right now, by the way, except data. So this is a little bit redundant in this case, but I think it's a great idea to always do this so that the code scales to having multiple state fields in the future. And then data is set to the value of this local variable here, which is this array of objects. All right, that's how we can load and parse CSV data.